Good afternoon. My name's Ken Rice. I'm Chief Operating Officer and Chief Financial Officer of Meta. Did this work? Did it go forward? Yeah, okay. So we're a public company listed on NASDAQ under MMAT. I will be making forward-looking statements today in my presentation. I encourage you all to look at our various SEC filings to find out more. So Meta is a company that is focused on delivering breakthrough performance across a wide range of applications and industries. We design, develop, and manufacture highly sustainable, highly functional materials. What does that mean? I'm going to tell you in the next couple of minutes. So if you think about all the advancements in material science and technology over the years, they can all be kind of traced back to changes in fundamental materials. You know, we didn't leave the Stone Age because we ran out of rocks. We left the Stone Age because somebody invented bronze and figured out it was a better tool. And as you progress through to today, we went through the Industrial Age, Iron Age, then we found semiconductors, which resulted in these big giant computers. And then we took those semiconductors and kept miniaturizing them and shrinking them and making them smaller and smaller. So we came into what's now lovingly referred to as the Digital Age. And we've gotten performance and power out of this material that was unthinkable before. At the same time, we're now in the 21st century, and what we believe we're doing is enabling the age of invisible materials. What you see on the screen here are patterns that were done in the 70s, 80s, and through to a couple years ago in laboratories at research centers around the world. The goal was to figure out how to put patterns on surfaces to change the way heat, light, energy, and radio waves and such behave as they do in nature. So I always tell a story about Harry Potter. There's a thing in the Harry Potter movies called the Cloak of Invisibility, and you put it over and you can't see the people anymore. Well, we can actually make that because basically what it's about is changing the way light is reflected so you can't see what's in front of you anymore. Well, for years and years, these little patterns were made in laboratories. We didn't invent them, but what was happening was there was no way to scale them, and there was no way to design them quickly. So metamaterials, which are materials that control on demand functional properties of absorption, emission, transmission, guiding light, sound, energy, that sort of thing, they are typically created by putting these patterns on surfaces, be it glass or plastic or other sorts of things. And they create electrical conductivity sometimes they just reflect light or radio waves. But there was no way to scale them, and there was no way to design them quickly. So Meta was formed in part to design these things. We started out 11 years ago as a design house. We figured that if we could design these patterns on larger scale materials quickly, we could, and using new technology, in particular AI and machine learning techniques and computers, we could do in a couple hours with an engineer and a computer what used to take months and years to do. So what we say today is our advantage are three things: speed, scale, and cost. So if you look at the bottom left, you'll see a red, white, and blue kind of film. That was what our stuff looked like in 2020 and the same thing on the far right. What you can't see in each of those pictures is the fact that both of those films are very, very heavily laden with metal. They're conductive, they're completely transparent, and they can be used for a whole wide variety of applications, which I'll talk about in a minute. In the top frame, what you see is what we've spent the last couple years developing and spending capital equipment money on, which is the ability to make these things at scale rapidly. I know it probably looks like news printing, and in a lot of ways it is. It's roll-to-roll creation of nano-pattern materials, which has never been done before. So what's driving what we're doing? Well, we play in a lot of markets. We're playing in aerospace and consumer electronics and all kinds of things. But if you look at the things that are really driving the market opportunity today, it's these top ones. 5G is a big deal. 5G is an infrastructure play. It has lots and lots of issues with it, which I'll talk about a little bit when I talk about the applications. Electric vehicles, I mean, Everybody says they're going to have electric cars by 25, 26, 30. That's going to happen, and in order for those things to work, there has to be a lot more technology involved. In the whole Internet of Things, there's a $3 trillion estimated market today in the Internet of Things, in advanced materials, and medical, and energy. And what's driving some of that, and we think most of it actually, is the fact that today, most of the work that's being done in this type of material use is in using rare earth metals. So everyone in this room has a cell phone, I guarantee you that you do. The screen on that cell phone is made with something called indium tin oxide, ITO. That's a rare earth metal. It's very expensive. Most of it is concentrated in China. It's hard to find, but it's the only way your phone works. It's a ceramic metal that conducts, so when you touch it, it's like touching a switch. We're running out of ITO. We're running out of other rare earths. Meta does not use them. We use commodity metals to perform the same function better. If you look at the device market, according to Lux Research, it's expected to grow to 10.7 billion addressable by 2030. So it's a very, very large opportunity for us. We have 5 technologies that we work on, 4 represented by one platform. We started our world in holography. We can use holograms to do certain things, we record holographic images on a photopolymer that allows us to reflect light. Our first product in that space was in laser glare protection for pilots. It's called Meta Air. And simply put, what we do is we make a grating on the surface of a film that's applied to eyeglasses that pilots wear to filter out green laser and let everything else through. It's very hard to do, but we did it. We can also use that same technology for head-up displays in cars, for head-up displays in airplanes, etc. We have a technology that we call rolling mask lithography. This is high-speed etching technology that we use on plastics to put our transparent metal into those plastics. We also use a different type of metamaterial film to enhance signals and images, in particular in the medical space. We're doing quite a lot of work in medical devices as well. And finally, we have integration technology that in a combination of augmented reality and in plasma fusion that allows us to make prescription AR glasses, for example. We're the only company in the world that can make AR glasses that satisfy the 50% of the world that needs prescription lenses. And Plasma Fusion is a company that we just acquired, a company called Plasma App about 2 weeks ago. The challenge that we face with our lithography products is that we first take a piece of plastic like you saw in the picture, we etch a pattern into it using this rolling mask, then we have to put metal into that pattern. Now this is very, very, very small. You can't see it without an electron microscope. So we melt the metal, we apply it to the plastic, and then clean it up. That's really challenging, and in order to get even distribution across a wide width of film, you have to go slowly. What the plasma fusion technology does for us is helps us go much faster. We can put any coating on any surface. I have examples from the guy that's done this work for us. I have a golf ball at home coated with stainless steel and another one coated with diamond dust, and he did that in like a minute and a half in both cases, and it's really quite exciting stuff. So we have a very broad platform of technology that we can now scale into high speed and high production volumes. So let's talk a little bit about the applications. I mentioned at the beginning that 5G is a big problem. Everyone has a phone now. How many of them say 5G on them? That's probably all of them, right? Well, myself included, they're spoofing us. 5G is a very strong promise that isn't there yet. The promise of 5G is to say we're going to transmit cell phone signals at up to 28 gigahertz in speed. And that will allow us to have, in a wireless world, the same thing we get now in a wired world. We can do large file transfers, etc. What you can see in this picture is that this guy up top here, the transmitter, sends a signal out. 5G, unlike 4G, requires line of sight. So you need to have the transmitters fairly close to where you want the signal to be. The problem with 5G is that about 85 to 90% of the signal, when it hits something like a window or a building, isn't reflected and it isn't transmitted into the building. It's just simply absorbed and you lose it. So 5G very rapidly drops to 4G and sometimes as low as 3G in terms of power. So the first thing we decided to do was we said, all right, how can we fix that? Well, one way to fix it is, what if that signal didn't get absorbed by the building but rather got reflected down to the street, so you could create a hotspot or create a hotspot in a different place? And we can put a pattern on the film, and you can see in the bottom left here, this outline, that's our film. That film has a pattern that reflects that radio signal back to the street, so the people walking on the street can get back to 5 bars, 6 bars instead of having no bars. Very simple product, doesn't require any power, it's passive. It can be applied to glass, to brick, to all of the above, and it reflects the signal to cover dead zones. The carriers, the alternative for the carriers in this case, is to put more and more transmitters everywhere. You have to put them on both sides of the street and crisscross them and do that sort of thing. So we are working with a Japanese company called Sekisui, who's working with us in Japan to start with, to do this reflector technology both externally and as equally important on the inside of a building. Because if you think about what happens in your house today, when you get Wi-Fi, you put repeaters everywhere to make the signal move around. We do the same thing with 5G. So what if you want the signal to come in? Well, our technology, by simply changing the pattern on the surface of the film, we can make the film become not a reflector but an inflector. So we can treat it like an antenna. So the signal will come, hit the window or hit the building and go through by virtue of the fact that our film is enabling it to happen. This is a huge opportunity, and what it does for us is it allows people that use 5G and want to take advantage of it, the full access to the 5G signal. We're also working in automobiles. Everyone sort of knows the electric vehicle world is coming. Today there's a lot of electric cars, but there's also regular cars. I drive a RAV4 and it has this really cool sensor on the front of it. And what it does is when I drive at night, I put it on automatic and it puts the high beams on and off when it thinks it should, unless it's raining. Because if it's raining, the sensor fogs up and it doesn't know what to do, so it just doesn't do anything. We can use the same nanoweb film and apply a little bit of power to it and keep that sensor defogged all the time. We can also keep the ice off of it. So this technology can be used for windshields. It can be used, as we mentioned here, LiDAR. LiDAR is a huge technology boom to especially the ADAS vehicles and automotive electric vehicles, because it's light-activated radar. So it's more sensitive than regular radar, but it has the same problem. It needs to be completely fog-free and it needs to be ice-free. We can't use wiggle wires like we do in the back of the windows today. They put those, the grids that they put in car windows today, because when you put those wires into a window, it blocks the signal in the LiDAR. So the LiDAR doesn't work anymore. Ours is fully transparent, doesn't interfere with the LiDAR signal at all. We also make transparent sensors and 5G antennas. I don't know how resolved is this. If you look at the right image, there's a little bit, it looks like almost like a rainbow between the tree, the big wooden tree, and the branch. That's actually a picture of our 5G film. It's an antenna that can be used on a telephone or on pretty much anything at that point to make the signal better and stronger. I mentioned we can do AR, augmented reality. We have a lot of work going on today in combination with Covestro, which is one of our partners, to do AR fusion. It's a huge market, it's an embryonic market, and we're very excited about what we can do in this space as well. I mentioned medical. I'm going to go very quickly through this, but we're able to do a combination of image enhancement and sensor enhancement in a variety of applications in the medical space, and we'll have more to talk about that in coming months. We are a B2B company. These are the type of customers that we work with. Some of these are already partners and some are targets. From a competitive standpoint, it's a very competitive marketplace for us. We started thinking that we were part of the semiconductor world, and we kind of are, but they can't scale to the sizes that we need, so we had to do it ourselves. In most of these other buckets, when we find companies that we think are competitive, we go to talk to them, and it turns out most of them want to be partners with us as opposed to compete with us. Because we are the only metamaterial company listed on NASDAQ right now, and we can do things from a performance and production standpoint that nobody else is able to do. We are IP driven. We have over 269 patents right now active and pending. We write our patents to not trade. We're not intending to trade this technology. We're intending to keep our moat full of crocodiles and keep everybody out of our sandbox. So it's something that we pay very close attention to, and it's served us well up until now. Since in the past year, in particular, we've put together a fairly strong executive team. When I joined the company 15 months ago, it was kind of lonely. It was George Palikaris, our founder and CEO, myself, and Dr. Waldron, who is our Chief Technical Officer, and Demos Callos, who was the co-founder of the company. Now we've added a number of more people to the group. They're very strong players in different functions, and we're continuing to add staff as we go. So how do customers work with us? This is one of the questions I always get. When customers, for many years, customers came to us as opposed to the other way around. They found out what we were doing, they heard about us and said, hey, I have a problem, can you help me? And the way we tend to work with them is they would come to us and say, okay, we want to talk to you about the different platforms that you have. I'll give you an example. Sekisui came to us and they said, we want you to make us a reflector for 5G. And we said, okay, we can do that. The way we started was we did a design. That usually took, as I said, a day or two. We'd give them 15 or 20 different designs that they could pick from and test. And then we have what we call wafer scale, which is what the semiconductor industry does. We can make our films at small scale, this big, in these boxes, and we can put the pattern on them, and we can make them very quickly and send them to the customer and say, okay, test this with different patterns and tell us which one you think is good. And that usually takes, the whole process takes the better part of a year, and it fetches us anywhere from $500,000 to $1.5 million in non-recurring engineering revenue and sample fees and such like that. As we moved into the second half of this year, in particular, we are building a new facility in Halifax, and we have an extra facility I'll tell you about in a second that will allow us to scale up what that same customer wants to have to square meters at a time, where we can make hundreds and hundreds or even thousands of square meters at a time. And that's where the long-term production comes from. And we now have the ability to do that both in our Pleasanton facility in California, and we're ultimately going to have it in Canada as well. Some of you, if you've done any reading on us at all, noticed that we bought a company last fall called Nanotech Security. Nanotech is in the banknote and brand security business. What they do, the United States is one of the few countries that doesn't have holographic security features on their banknotes, but everyone else does. So if you've been outside or even to Canada, you look at the Canadian bills, you can flip them around, these really cool holograms that show up. We make those. And what Nanotech brought in the biggest abundance to us were additional technology synergies. They brought the ability for us to make our own masks, so we don't have to use other people's technology to do that, et cetera. But they also have a 100,000 square foot facility in Thurso, Quebec. And that facility is capable today of producing 7.5 million square meters a year of film. They produce it at $3 a square meter cost, which is ridiculously inexpensive. We want, for NanoWeb, for our product, we want to be at about $10 a square meter, because that gives us the ability to be the low-cost producer of our own product, and we can play in any of the verticals we want to be in, be it really high volume or really low volume, and make the kind of margins we need to make. So Nanotech brought with them not only technological synergy, they brought an assembled workforce of about 52 people. They brought a 50 million plus contract with one of the top 10 central bank clients for making security features for their next generation of banknotes, and they brought the facility. So we're really pleased with that. And as I mentioned, we just bought the company that does this high performance plasma coating, and we can basically put any solid material on any substrate. they're playing in our space in metallization of nanomaterials, and they're also active in the lithium-ion battery space. You can look at our financials. I won't talk you through these. They're hard to read anyway. Short course is we've been around for 11 years. We ended last year with about $50 million in the bank. Our burn rate's somewhere between $2.5 and $3 million a month right now. We have $110 million of capacity left on an ATM. We're public on NASDAQ, and we think that last year showed a fairly large loss. I think it's $90 million. A lot of that had to do with the fact that we merged with our partner that got us on NASDAQ, and we bought Nanotech, and we bought PlasmaApp, and we spent a lot of money in SG&A. That number is going to drop this year. And so I think the way to summarize is we are a company that has done a very credible job of growing. We have multinational subject matter experts. We have 150 people today, 50% of whom are PhDs. We have actually, oddly enough, 29 languages spoken in the company. We are a very big and growing IP estate. We have tools that we've developed that are very proprietary, both from a design and simulation standpoint, plus the production stuff, and our stuff is scalable. We are a B2B company. We have global partnerships with a number of OEMs and Fortune 500 companies. We're the first metamaterial company on NASDAQ. And we have, luckily enough, a lot of our stuff is in Canada. We're actually in three places in Canada. We're in Athens, Greece. We're in London, England. We're in Oxford, England. We're in Boston, in Massachusetts. And we're in Pleasanton, in California. But the bulk of our operations are in Canada, and that allows us access to very large amounts of Canadian government funding, which is very attractive. It's either interest-free loans and or grants. And with that, I will take questions.
On your balance sheet, you have like $75 million for assets up for sale and preferred stock dividends.
Okay. When we did our merger with Torchlight last year, Torchlight was a reverse triangular reorg that got us a NASDAQ listing. Torchlight was an oil and gas company based in Texas. We are anything but. We are a sustainable company. We're a clean tech company. We actually have multiple awards for being a clean tech company. So we said, all right, we don't want to be in the oil and gas business. So when we structured the transaction, it should have been probably 50-50, 60, 55-45 in their favor. It came out 75-25 in our favor, but they got to keep the oil and gas assets. The plan was for them to sell those assets over the course of the rest of 2021. They're still on the balance sheet now because they're going to be spun out. We announced that a couple weeks ago. So it's just a washout. So the liability and the asset balance offset each other.
Since you're so high-tech material, I would think that your gross margins would be really high because you're offering a product that is so specialized that they're 25%. Do you have the ability to get 60, 70?
Yeah, that's a great question. Thank you. The margins that you're seeing in the P&L now are predominantly driven by what the revenue mix was, which was, especially in 2021, it was a combination of non-recurring engineering on what we call traditional meta and the banknote business, which is, again, contract engineering for Nanotech. So as we move to product and away from NRE, we're not taking business that is less than 50% margin. But in order to do that, we have to lower the costs. They're telling me I have 1 minute. I can take probably one more question. Okay, thank you.